Welcome to another unit in this methodology toolbox. This time I want to say a few words regarding conducting tests or test theory in general. Let's start with the idea. If you want to test something, well, you need something to test, and that's usually a hypothesis. So what are hypotheses? Well, the central criteria for a hypothesis is, first off, it needs to relate to some kind of empirical context. So you actually need to be able to collect data to test the hypothesis. Then it needs to be general. It's not about one single case, it's about the general situation, a general link, a general difference between groups of things. It needs to be formulated in some kind of conditional formulation, as in if this, then this. As there is a difference between group 1 and group 2 could also be translated into if one is in group 2, then the value whatever is different than as if one were in group 2. So it always needs to be either directly be formulated as a condition or be able to be reformulated in a conditional formulation. And finally, that's the most important one, it needs to be falsifiable. So we always need to be able to disprove our hypothesis, because that's the biggest problem here. We will never be able to prove a hypothesis. We will only be able to falsify it, to actually refute it. And that's how we actually work with our tests later on. We always conduct or pose one hypothesis, try to refute this. If we can refute this, then well, the exact logical opposite needs to hold true. So if we actually pose as what we test the opposite of what we want to show, then this proof that the opposite is true, what we wanted to show, has to hold until there are different new insights which might disprove it again. But that's the main idea how our tests will work. Again, to make the hypothesis a bit more concrete, we can talk about the content, the direction, and the specificity of a hypothesis. What does this mean? Well, the first part, content, means are we talking about relations, associations, or are we talking about differences? That's the first point of difference for hypotheses. We can talk about directions. Are we talking about a one-sided or a two-sided test? Meaning, does the hypothesis state something as there is a difference between group 1 and 2, or group 1 is larger than group 2? First one being undirected, meaning a two-sided test is required. The first one is directed, larger than, smaller than are directed, meaning a one-sided test is required. And specificity means, do we just say larger than, or do we say at most 50% larger than? So do we hold it very general, or do we actually give a certain value which need to be fulfilled? That would be specific or unspecific. With all these backgrounds, as I already said, we have two hypotheses we consider. The null hypothesis, the alternative hypothesis, or H0, H1 hypothesis. The H1, that's what we actually want to show. So we build the exact logical opposite, that's the null hypothesis. That's what we're going to test. And our goal is to actually refute the null hypothesis, disprove the null hypothesis, because then the only thing which is left would be the alternative hypothesis, and that's what we wanted to show. That's the main idea. However, we will always make some kind of errors, because nothing can be done error-free in an empirical environment. So it's important to talk about errors. In this context, we can introduce two types of errors, and I'm going to do this with this example here. We can consider we have our patient who's either healthy or sick, and he goes to a doctor. Doctor poses a diagnosis. He says either, well, according to what I see, I deem the patient healthy, I deem him sick. Well, in the case that we have a healthy patient and the doctor deems him healthy, that's good. That's a correct assessment. Same as we have a sick patient and the doctor deems him sick. That's actually the results we want to have. The problem comes up if we either have a sick patient who the doctor calls healthy, or we have a healthy patient who the doctor calls sick. Those are errors. However, well, if a healthy patient is treated, that's not this big of a problem. The real big problem occurs up here. We have a sick patient who is not treated because he's considered healthy. That's why we call these errors type 1 error and those ones type 2 error. Or another determination sometimes also as the alpha error and the beta error. Of course, if I try to build my test in a way that it reduces the beta error, I will get a larger alpha error. If I try to build the test in a way that it reduces the alpha error, it will increase the beta error. That's always a trade-off I have there. And I will get back to this trade-off in a moment. However, well, we have the type 1 error, but we also have different names for it. One of them I already said, that's the alpha error. But it could also be called a false positive, meaning the type 2 errors are then false negatives. Could also be called the significance level, which in many cases is what is reported by a statistics program, or the p-value. Again, that's something which you can find in a statistics program. Well, how does this link to the hypotheses we had before? Well, this is also the probability that our H0 hypothesis, the one we test, is correct. So if this type 1 error is small enough, then I can refute H0 without making too much of an error. So I'm always striving to get a p-value, type 1 error, as small as possible. So the question now is, what is small enough? So which significance levels do we differentiate between? Well, this goes back almost 100 years with Fisher, famous statistician, saying, well, 1 in 20 might be acceptable. 1 in 20, meaning 5%. This gave us the base idea what significance level might be low enough. However, we differentiate this a little bit more. If we are a bit more relaxed, we can also say, well, we accept not only 5% but 10%, but we call this weakly significant. The 5%, that's what usually referred to as a significant relationship. Our error is smaller than 5%, is smaller than 1 in 20. Actually, interesting insight was that if we aim for an error of 5%, that's actually an error where alpha and beta error are approximately the same, and the sum of both of them is as small as possible. That's an additional insight. Well, if we are a bit more stricter, we could also say, well, we do not only want to have significant results, we want to have highly significant results that would be smaller than 1%, or we want to have a result with almost certainty, which here would be less than 1 per mil, or 0.1 percentage point. Those are the different significance levels we differentiate between. That's what we might consider an error which is small enough. As I said, standard being 5%. If we have an error which is smaller, then we can reject H0. Then H1 is the hypothesis we go for. Well, this already then concludes this session on test theory. I hope you enjoyed it, and I say goodbye and see you next time.